Today we will be doing a very important part for the wave optics, and that is what we call Young's double slit experiment. Okay, in short you can call it as YDSE, Young's double slit experiment. Now this is just we have already done, if you must have seen in the last class when we are done with the interference. So when we do with the Young's double slit, Young's was the name of the scientist, double slit experiment. So we need two slits here. So here let us first see the diagram. This is your parent source, okay, and we will have two slits. Let us assume this is S1 and we have another slit out here. This is S2, okay, and we have got a screen here. Now just I would like to take this is one part, this is the middle. Okay, let us assume this is point O. Okay, now see, this is your parent source. This is what I call this as the parent source. And this S1 and S2 are the two slits. The distance between the two slits, we take it as small d. So what is small d? Distance between the slits. What we have, this is your screen, okay, and the distance from the slit to the screen is capital D. So what is capital D? Distance between the slits and screen. So from here to here the distance is capital D. Now why we have taken two different slits from the source S? Because we want a coherent source. That is the reason we have taken, because we want the coherent source. And if you remember in the last class of mine, I had already explained what is meant by the coherent source. Now coherent source is that source which, suppose if you get the waves from here and here, they will have a phase difference constant, and this should be constant in course of time. Okay, that is the meaning of coherent source. Now the point O can be a place of center. Always you find that, suppose if the rays is coming from here and another one is coming from here, so the path difference, the distance between S1O and S2O are same, so the path difference is 0. So O is the position of always bright fringe, okay, or it is constructive interference. Now, not necessary that always we need constructive. Let us assume we have taken point P here. The distance from S1 to P, let us take, this is the distance, and we have taken other distance from S2 to P. So this is your path difference. This is your path difference N. Okay, so we take this as theta. Okay, we take this as theta. Now here we find this is theta. So theta is the angle that we have for this, and S2N becomes what? S2N becomes the path difference. Okay, why? Because the distance of S2P is more as compared to S1P. So we need to find out this S2N. If we can find out the value of S2N, then what we will do, we will put up the construction interference condition and destructive interference condition, and ultimately we'll get the width. Now one thing more, the distance from this position Y is, we have taken Y is the distance from the central till this particular point, which can be a constructive or which can be a destructive interference. Now if you look into this triangle, in triangle S1 S2N, we have got, if this is theta, so this is perpendicular and this is your hypotenuse. So we can have sine theta as equals to S2N divided by S1 S2. Now S2N, S1 S2, the distance between S1 and S2 is what? Small d. So let's write small d. So this is small d. Okay. Now next you see this triangle. Look at this triangle. Okay, this triangle. Now tan theta, if we take tan theta is equals to perpendicular, this is y, and this is from distance from here to here is capital D. So we can write y by capital D, because from here to here is the perpendicular y, and from here to here it is capital D. Now since angle is very small, we know that from the expansion of sine, if the sine theta, if the angle is very small, then we can write sine theta as equals to theta. So what we can write? We can write sine theta as equals to theta. We can write sine theta as equals to theta. So sine theta is nearly equals to theta, and this is nearly equals to tan theta also. So we can write like this. Fine. Now look at this. So we can write these two equations same. S2n by small d is equals to y by capital D. Or we want to find out S2n is equals to y small d by capital D. So this we have got the path difference. What we have got? This is your path difference. Suppose if I want to find out for the constructive interference, if you have seen my last class, then you must be knowing that for constructive interference, this is what we are calling this as the path difference. Path difference S2n is the path difference. So this should be equals to m lambda. So let us substitute this as m lambda, and this is yd by capital D, or where m value will 0, 1, 2, 3 dot. So here y we are getting as equals to y is equals to m d lambda by small d. Make it equation 1. Now when we look for the destructive interference, what we will have? We'll have this value as equals to 2m minus 1 lambda by 2. Now this will be equals to y small d by capital D, because path difference we have already got this value, y is small d. So let us substitute this value in that equation. Let us substitute this value in this equation. So ultimately we are finding out y. If you substitute, you are getting this as 2m minus 1 lambda d by 2d. Okay, so this becomes m minus half, okay, d lambda by small d. Now this is the condition that you have got for the this is what you have got for the destructive interference, but we are looking for the fringe width. We look for the fringe width beta. We denote it by beta. It is the consecutive difference. If you get to see on the screen, you get the dark patch, and ultimately you get the bright in the middle and dark in the opposite side. So we are measuring the width of it. So here in the bright fringe, what equation we had got? We had got y suffix n. Suppose if I take y, then it should be n d lambda by small d, and y n plus 1 if I substitute, so it will be n plus 1 d lambda by small d. So suppose if I want to find out the width of the bright fringe, for bright fringe, it will be y n plus 1 minus y n, that is equals to beta, and this is equals to, if you subtract these two equations, you will get this as d lambda by small d. So what ultimately you are getting the condition that the fringe width beta is equals to d lambda by small d. This is the equation that we have derived. Okay. Now for if you find out for the dark also, then you will get the same thing. You will be getting the same formula. So if it is bright or dark, fringe width beta is equals to d lambda by small d. Now this equation shows that if the distance between the slits is less, fringe width will be more. If the distance between the slits and the screen is more, beta will be more. So I hope you must have understood this Young's double slit experiment. This is a very important derivation when you do with the wave optics. So kindly go through it. Make sure that you understand complete, because if you understand, you'll be able to do the numerical problem. Lambda is the wavelength of the light used. Okay, I again repeat, beta is the fringe width, d is the distance between the slits and the screen, lambda is the wavelength of light used, and small d I already told. So this is how we go. Okay, thank you for watching.